All right, suppose we want to discover a formula for finding the area of a circle. Well, what do we already know about a circle? We do have a formula for its circumference. We know that the distance around the outside of the circle is 2 times pi times r. So we can see that pi, the constant, is involved, and the radius. The only thing we have to know to find the circumference of a circle is how far it is from the center to any point on the circle itself, and you can find the circumference. Turns out the same thing is true for area, and here is an informal discovery. So I've constructed a circle, and I've clearly labeled the radius, and then I've also clearly kind of highlighted the outside of this circle, the ring. There's my circumference. If I take my circle and I fold it in half, I fold it right along the diameter that I drew, and I fold it in half again, and I fold it in half again. Each of these little shapes that I'm making kind of looks like a slice of pizza. They're called sectors, and I could do that. And when I unfold my circle, I can see that it's kind of difficult to see the crease marks, but in each one of these quarters of the circle, there are 1, 2, 3, 4 smaller triangles that I have made, okay? So there are a total of 16 smaller triangular slices. They aren't technically triangles because of the arc out here, but they're really close. So what I'm gonna do is I'm gonna take a pair of scissors and I'm gonna cut the circle up, and the key is I'm not throwing any part of it away. So I'm gonna cut it into these slices, if you will, and when I'm finished, I'm gonna have 16 of them, okay? And you can see that as I cut them, the circumference is clearly visible, the portion that was the circumference. Likewise, the radius is also gonna be visible, and I drew the radius in a couple of places, right? Okay, so when I'm finished, I would have 18 of these slices. I'm going to do with the circle what I did when we discovered, say, the formulas for the area of a trapezoid or a kite. I'm going to rearrange it into a shape that we already know how to find the area of, and then therefore inadvertently discovered this area formula. So what I'm going to do is I'm going to take each of these slices, and this is my radius, so that's how far it is from here to here. And I'm going to put another one next to it like such, and I'm going to vary them back and forth, just kind of wedging them against one another like that until I end up with this, okay? So these are all 16 of those slices that I was able to cut when I dissected that circle. I've not changed the area. Area is two-dimensional. It's a flat surface. So this circle covers the area from my left hand to my right hand and top to bottom. You can see that this loosely resembles a rectangle. And the cool thing about this is we know how to find the area of a rectangle. It's just the length of its base times its height. Well, how high is this rectangle? It is standing roughly a radius high. I could use r to label the height. Likewise, the distance across the bottom, you can see that every single one of these slices has been shaded with my black marker. So that was around the outside of the circle, right? It's part of the circumference, but it's not the entire circumference because the rest of it is up here. So part of it is on the top and the remaining portion is on the bottom. So literally half of the whole circumference, and that's the formula for circumference, is along the bottom of this new rectangular sheet I've made. Well, if I multiply those are going to cancel out, and I can see that a good description for the length is pi times r, or the base, and the height is r. And how do we find the area? We take the base, which is pi r, and we multiply it times the height, which is r. Finding the area, and so you can see that the area of a circle is equal to pi times radius, the radius squared. Looks really similar to the circumference formula, right? There's a 2 only that 2 is not acting as an exponent, it's a coefficient. This is how you find the distance around the outside. This is one-dimensional. It would just be whatever the units are, it would just be feet or miles or meters. This is two-dimensional, so whatever the units are squared. So you might find the area of a circle in square inches. Okay, this is the formula for the area of a circle, and that was a really quick informal discovery. Had we been together, we would have done that construction, and you all would have that in your notebooks, but we aren't. So let me show you what Geometry Nation wanted us to do. I'm not going to fill all of this in. I'm just going to cut to the chase. What they give us here is we have a hexagon. And I hope that you remember that the area formula for any regular polygon whatsoever is half of its apothem, which is this distance from the center perpendicular or straight at the edge, times the perimeter, the total distance around the polygon. This has 6 sides. Well, what if instead it was an octagon and it had 8 sides? That's a really poor drawing of something that was supposed to resemble an octagon. But my point is, the number of sides that a figure has, as that increases and gets larger and larger and larger, this starts resembling, it gets closer and closer looking to a circle, the more sides it has. Now, I think we can agree that a circle doesn't have sides. So the limit, this approaches a circle as we add sides, but keep this distance the same. But in theory, the formula is still the same. It's still half of its apothem times its perimeter. Only when we go from the center to an edge on the figure, the apothem is more appropriately called the radius in a circle. And remember, we don't use the word perimeter for the outside distance around the circle. We use circumference. And the circumference formula is 2 times pi times the radius. So if we clean this up, half of 2 is just 1. That's going to cancel. And we're left with pi times radius, or pi r squared. Okay, and that's what they wanted us to discover on these 2 pages. My apologies for the upset sandhill crane right outside my window. All right, let's do some practice problems with that. So remember, I'm going to write the formula. I'm going to plug in what I know. I'm going to solve for what I don't know. I'm going to pretty much finish the year with that mindset as I try and solve these problems. All right, so what we have is a circle. We know that its diameter is 18 inches. We're going to find both the exact answer, so we'll leave it in terms of pi, and then an approximate area, and we'll do that by rounding to the hundredths. So you're going to need a calculator. And so because I'm looking for area, I know the formula I'm going to use is pi r squared. We haven't been given the radius, but of course that's easy enough to find. It's just half the diameter. So the exact answer is going to be pi times our radius squared, and 9 squared, we end up with 81 pi. And the units were inches, so because we're finding area, it's square inches. That's the exact area. If we want an approximate area out of that, we're simply going to take our 81. And if the problem doesn't specifically tell me to use 3.14 for pi, I'm generally going with my scientific calculator and I'm using the pi symbol. So that's going to round to 254 and 47 hundredths. And it's square inches. Okay, all right, number 2. Dale is spreading grass seed over a putting green on a golf course. The circular green has a radius of 30 feet. If each bag of grass seed covers an area of 315 square feet, how many bags are we going to need? All right, in order to answer that question, we need to figure out what the total area is. And I'm not going to round until the end if I can help it. So the area is going to be pi times our radius squared. 30 squared is 900. So that's the exact area. The radius was in feet, so that's square feet. Well, what are we going to do? We're going to take that total area, and each bag covers 315 square feet. So you can see that basically the units cancel out. We're just going to end up with a number, and that number is going to represent the number of bags we would need. So I'm going to take 900, multiply it times pi, and then that's going to need, 900 times pi, that's going to be divided by 315. All right, so we don't get a nice, neat answer. That's not surprising because pi was involved. However, I need more than 8 bags. I need approximately 8.98 bags, but we know we can't buy that many. So when we go to the store, we need to purchase 9 bags of the seed in order to get the job done. All right, a sidewalk bounds a circular park, and the parents exercise by walking and their children play. All right, so here's the area where the children play. Here's the sidewalk where the parents walk. We know how far it is around the inner edge of the sidewalk. Meters around. And notice it's meters, it's not square meters. This is our circumference. Okay, we want to find the approximate area inside of here where the children are playing. In order to find that, area equals pi r squared, I just need to know the radius. So we're going to start with this formula and plug in what we know. And we've been told that the distance around is that, and we know that that's equal to 2 pi r. We're going to solve for what we don't know. So the only thing I don't know is the radius. Let me go ahead and divide by 2 pi. Okay, I'm going to clean this up just a little bit because this ends with an even digit. I can cut it exactly in half. So we get 628 and 32 hundredths over pi. Now that's really ugly, but that's exact. That's the radius of this circle. So I'm going to bring it over here and I'm going to put this in place of the radius. Plug in what you know, solve for what you don't know. So it's going to be pi times, my radius is pretty ugly, so I'll go ahead and use my parentheses, the 628 and 32 hundredths over pi. Okay, I'm going to let my calculator do all the rest of the work here. So I'll start by, I'll go ahead and use parentheses. I'm going to square this first. So I get 628 and 32 hundredths divided by pi. I'm going to close that off, and then I'm going to hit the squared button. And then that is going to be multiplied times, I've got another pi out there. Hit equals, and there's my answer. I'm going to go ahead and round this. It doesn't really tell us where to round, so I think I'll just round to the nearest whole number. 125,664. Well, let's go ahead and round to the hundredth since that's how far out we went in terms of our circumference, okay? And the units are meters, so our area, don't forget, is square meters then. All right, last try it problem. Most road and racing bikes use rims that are 3,038 and 5,800 square centimeters. And though some bikes with smaller riders only use this many square centimeters. So what they have given us in terms of these bikes are the areas of the tires, okay? We have a large rim and we have a small rim. And I know that the large rim has an area of 3,038.58 and the small rim is 2,560.52. We want to find the difference in their diameters. Well, in order to find the diameter, I need to know the radius. And since I've been given the area, I should be able to come back off the formula. So area is equal to pi r squared and solve for r. I know the area of the large bike. I'm going to plug that in on the left side. 3,038 and 5,800 hundredths. That's equal to pi times the radius squared. I also know the area on the small bike. The area, plugging that in on the left side for A. I know what the area is. I don't know what the radius is. So I'm going to solve both of these for R and just know that this is a little ugly initially, okay? So I want to get R by itself. So the first thing I'm going to do is divide by pi. So I'm going to try not to round until it's kind of too painful not to round. So here's where I'm at. And r is not alone because r is being squared. So if I want to solve for r, it's going to be the square root of that, okay? So r is equal to the square root of 3,038 and 58 over pi. That's the radius. How do we find the diameter? This is the radius of the large rim. So this will be the diameter. We're going to double that. So 2 times this is going to be the diameter of the large bike. Let's go ahead and we'll get an answer for that, okay? So what I want to do, this calculator, I type it in like I see it. You might have a calculator where you have to do the division and then take the square root. But on my calculator, I'm going to take the square root of that quotient. 3,038 and 58 divided by pi, and I'm going to close off it opened parentheses, I'm going to close them off. That's the square root of all of that, and then I'm going to double it, multiply it times 2. So my diameter is roughly 62.2. Okay, let's do the same thing here. So we'll just get to practice this one more time. I'm solving for r. So r squared is equal to this really ugly quotient. But I'm not done because I need to take the square root. I want to know what r is. Okay, so r is the square root of all of that. And then if I want to find the diameter, I'm going to double that. 2 radii equal a diameter. Okay, so the diameter of the small rim is roughly, so again, I'm going to take the square root of, it opened my parentheses, 2,560 and 52 divided by pi. I'm going to close that off. I hit equals and then times 2. And I end up with, to the nearest hundredths, about 57.1. And these are going to be centimeters, okay, because our area was given to us in square centimeters. So now I have what I need to know to answer the question. I want to know what the difference is in those diameters. So the large diameter minus the small diameter. And we end up with a difference of about 5 1/10 of a centimeter. Okay? All right. Beat the test. Let's do this last question together. A sprinkler rotates in a circular pattern and sprays water over a distance of 25 feet. What is the approximate area of the region being covered by the sprinkler? All right, we're finding area, right? So we simply need to use the formula pi r squared. So our area is going to equal pi times 25 squared. 25 squared is 625. Don't forget to multiply times pi. So the approximate area then, 625 times pi is roughly 1,963.5. That's going to be B.